Algebra 2, we are in section 2.4 today. I think we're going to get it all done in one day, so we'll see how it goes. First, we're going to warm up and remember what we've learned in the past. Multiply the polynomials. When we have two binomials, that means two terms in parentheses, to multiply them, we FOIL. Okay, first, outer, inner, last. So first times first, x squared, outer, 3x, inner, 2x, and last is 6. Collect your like terms. I sort of go over this fast because this should just be a really simple review for you. Another binomial. Here I have the same binomial but with a positive and a negative. This is going to give me the difference of two squares. So first is 4x squared. Outer is positive 2x, inner is negative 2x, which is going to cancel out. Then last is minus 1. That is the difference of perfect squares. This one is a binomial squared. And if you remember the pattern here, it's the first term squared, and then 2 times the first term times the second term, and then the last term squared. This just means I write it twice. I'm going to show you the work now. First, outer, inner, and last. Those inner terms collect to give us negative 14x. So there's our answer. This one's the just distribute. Okay, we like these because we've known how to do them for a while. 15x squared. Okay, it looks like we factored out the greatest common factor from these two items, which is a 3 and an x squared. The dimensions of a box are modeled by that. Write a polynomial that models the volume of the box. You remember length times width times height is volume. So we take two of these binomials and FOIL them. So first, outer, I've got 2x and 4x, which is 6x, and last, which is 8. And I'm going to set up a box to model the last multiplication, the trinomial times the binomial. So I have x cubed, 6x squared, and 8x. 6x squared, 36x, and 48. Now collect like terms gives me x cubed, 12x squared, 36 plus 8 is 44, and 48. That right there models the volume of that box. Alright, here's what we're learning. I've got factoring. So a general trinomial is always going to factor to two binomials. This is where we learned to do AC, so negative 40, what multiplies to negative 40 and adds to negative 3. A perfect square trinomial, when this one is a perfect square and that's a perfect square, and that is twice the terms, twice the first times the last, I get a perfect square trinomial. Difference of two squares. When this is a perfect square, subtraction, and this is a perfect square, it becomes a plus b, a minus b. And then the common monomial factor. We had one of each of these in our warm-up. So here I just factored out the greatest common factor. So we've learned how to do all of these. This is what you know. You've got this in your toolbox. Life is grand. But you can also factor polynomials with degree greater than 2. Some of these polynomials can be factored completely using techniques you've previously learned. So what does factoring completely mean? A factorable polynomial with integer coefficients, that means numbers in front of the letters, is factored completely if it's written as a product of unfactorable polynomials with integer coefficients. Okay, so we factor it completely means that we can't factor anything else. So let's look at an example. 2 times x plus 1 times x minus 4 and 5x squared times x squared minus 3 are factored completely. Each one of these binomials or monomials, this binomial, I can't do anything else with it. Even this one right here, I've got x squared minus 3. This is a perfect square, but this is not. So I can't factor it any further. If I look at this one, 3x times x squared minus 4 is not factored completely because this binomial is the difference of perfect squared, and I can factor it to x plus 2, x minus 2. So knowing if something's factored completely comes with practice. And we're going to keep on practicing, right? All right, so let's factor completely. I have a trinomial here. So I can find a common monomial factor to take out first. It looks like everything has an x to it, so I'm going to take out an x. There aren't any, sorry. Okay, my kids turned on the TV. It got loud. I factored out the x. There's no numbers that I can factor out. There aren't any numbers I can factor out. Try for some proper English. So if I factor out an x, I have x squared plus 2x minus 15 left. Now, can I factor this trinomial? Is negative 15, can I take anything that multiplies to negative 15 and adds to negative 2? Let's see. Factors of 15. 1 times 15, 3 times 5. Looks like if we have negative 3 times positive 5, that adds to positive 2. So leave that x out there. I've got x squared minus 3x plus 5x minus 15. Okay, factor by grouping. I take out an x. I have an x minus 3 left. I take out a 5. I have an x minus 3 left. And this x is still hanging out, right? Now we take out the x minus 3, which is common, and we have x plus 5 left. So there we go. We have been factored completely. Okay, I'm going to grab this one and take it to the next slide. We want to factor completely 2y cubed minus 18y cubed. Sorry, 2y to the 5th. So let's find our common monomial. It looks like I can take a 2 out of both of them, and I've got at most 3 y's in that second term. So in the first term, I have y squared left when I factor out the 2y cubed, and I have 9, nope, just 9. Am I done? Well, this looks like the difference of perfect squares. So I can factor that again. I get y plus 3, y minus 3. And now I'm done. Okay, let's look at that last one on your paper. It's 4z to the 4th power minus 16z cubed plus 16z squared. Cool. Look for that the common monomial. Looks like my number that's common is a 4, and the most variables, the least variables I have, the most that are common in all of them is a z squared. If I take that out of the first one, I just have a z squared left. The second one, I can take out a 4, I have a 4 left, and a z, and that third one, just a 4. Now, can I factor this trinomial anymore? Is there anything that multiplies to 4 and adds to negative 4? It looks like negative 2 times negative 2. Ooh, this is a perfect square trinomial. I have z times z and 2 times 2. And this is 2 times 2 times z. But here it is. Let's do it the way we've always done it. So this hangs out here until I'm done. I get z squared minus 2z minus 2z plus 4. Okay, grouping. I'm going to factor out z, and I have z minus 2 left. and factor out another z, but negative, because when we have a negative number, we factor out a negative. 2, nope, I'm factoring out a 2. Sorry, I caught my mistake. Very confused. And that gives me z plus 2. But I factored out a negative, so that gives me a z minus 2. So those binomials are the same. Let's take those out. Z minus 2, and what's left? Z minus 2. Cool. I could also write it this way. All right, factoring patterns. In part B of example 1, the special factoring pattern for the difference of two squares is used to factor the expression completely. There are also factoring patterns that you can use to factor the sum or difference of two cubes. Okay, we learned this a little bit, but there's a little review here. So when I have the sum of two cubes, I can factor it like this. When I have the difference of two cubes, I can factor it like that. My example here is 8x cubed plus 27. 8x cubed is a perfect cube. It's 2x times 2x times 2x. And 27 is a perfect cube. It's the same as 3 times 3 times 3. So if you see I have a 2x here and a 3 there, I can write 2x plus 3. And then 2x squared is 4x squared. 2x times 2x is 4x squared. And 3 times 3 is 9. In the middle is 2x times 3. Okay, we learned this in an earlier section, so it's just a quick review. 2x times 3. So what I really see here is a plus b, a squared minus a times b plus b squared. And the difference of perfect cubes is a minus b, a squared plus ab plus b squared. Okay, so make sure you can see these when you work on these next examples. Okay, because we're going to use them. Factor the polynomial completely. What I usually do here while I'm learning, not grab my slide and move it around. I figure out what my perfect cubes are. Normally if you have two numbers that are maybe a little bit bigger with an addition or a subtraction, you've got a perfect cube trinomial. Perfect cube binomial. So I can break that into x to the third power and 4 to the third power, because 4 times 4 times 4 is 64. Now we can use that pattern. So I'm going to have x plus 4 and then x squared. So that's a squared minus a times b and b squared. And we're done. So this next one, okay, I've got two things with subtraction, but it looks a little crazy. I'm not sure what to do with it yet. I can factor out a monomial first. So 250 and 16 has a common number of 2 and z to the second power. What's left is 8z to the third power minus 125. Here I have the cubed, difference of cubes. So let me write this again. This first one gives me 2z to the third power and 5 to the third power. Now I can just use my pattern. 2z squared, I get a squared, which is 4z squared, minus b squared, which is 25. Oh, sorry, that's wrong. And I don't have my eraser. Let's do this. Sorry, let's try again. It's just a minus b. 2z minus 5. And then we have a squared. 2 times 5 is 10. And then 5 squared. Whew, sorry, too many mistakes in that one. Right, let's practice. So this is for 1 and 2. Look at it. Is there anything common that I can take out? Looks like I can take out an x. I have x squared minus 7x plus 10 left over. A times c is 10, negative 7. 2 times 5 is 10, and if they're both negative, it works out. X squared minus 2x minus 5x plus 10. Factor by grouping. I get, take out an x. I have x minus 2 left. Take out a negative 5. I have x minus 2 left. So x times x minus 2, x minus 5. Factored completely. Here, I'm hoping it's a difference of cubes. Let's see if I can factor out a monomial first. 3y cubed. That would give me a y squared minus 25. Oh, difference of squares. Cool, that's easier. 3y cubed. I've got y squared minus 25, which is the difference of perfect squares. That gives me y plus 5, y minus 5. All right. Again, I've got just 2 terms. I'm hoping for cubes or squares. So let's factor out our greatest, our common monomial. It looks like I can take out just a 2. That's crazy. I thought there'd be something more common between 16 and 686, but just a 2 and a b squared. Let's see, I have 8b cubed left and 343. Okay, I need my calculator for this one. Cool, 343 is 7 times 7 times 7. I do not have that one memorized. So what we have here is 2b squared, 2b cubed plus 7 cubed. So let's use our formula. 2b squared, 2b plus 7, 2b squared, which is plus a times b, which is 14b, and b squared. Except I think I have a sign wrong. Yep. Right, there we go. Oh, number 4 is a simple difference of cubes. Yay. W is a and b is 3. So that gives me w minus 3, w squared, so a squared, plus a times b, plus b squared. That was refreshing. All right, factoring by grouping. We do this. I taught you this as a way to factor trinomial, okay? But whenever you see 4 terms, so we have 4 terms here, you can factor by grouping. I'm not going to show you with this one because we've been doing it so much. I'm going to show you with an actual example. Cool? So factor it completely. Whenever I see 4 terms and I've been told to factor completely, usually factoring by grouping is what works best. So we always group the first 2 and the last 2. Find your greatest common monomial, which here is going to be an x squared, and I've got x minus 3 left. And for the next one is negative, because we always take out that negative, and 16 is common, and x minus 3 is left. Factor out your common binomial, and then you look to see if there's anything else to do. Here I have the difference of perfect squares left. So I can factor that, hopefully easy, x plus 4, x minus 4. We're actually going to pause there and finish the lesson tomorrow. So examples 1 through 3 today. Cool? Awesome. Good work today.